Viewers, welcome to this video this morning. I want to take you through questions here. Question 20, part A and B, C, and also part D here. So the questions come from the topic of equation of a straight line. So let's get started. So we have the first question here that reads, find the equation of a line which passes through point 3, 5 and -2, -4. So for us to kind of get the equation of a straight line, we have this standard formula. So we say this is y equals to mx plus c, and we already know that this y and x, these are variables. M is the gradient and c is the y-intercept. So we kind of have to pick the points here. We already have 3, 5, and we have -2, -4. So we need to find these quantities here. We have to find m and c, right? So m is the change in y over change in x, which we basically have to take like -4 -5 over -2 -3, and this is the same as -9 over -5, which is 9 over 5. That checks, so that's m. Now we need to find c. We have to pick one of the points. So if we pick this point over here, so x is 3 and y is 5, so y is 5. We got to substitute into this equation here. So we have gradient is 9 over 5 and the value of x is 3. Then we put c there. We need to find for the value of c. So again we have to simplify this. So we have 9 equals to 5 equals to 27 over 5 plus c. So we got multiplied by 5 everywhere, so this becomes 25 equals to 27 plus 5c. so you subtract 27 from both sides, you have -2 equals to 5c, and so c is like -2 over 5. So for us to get the equation, we need to substitute them there, but we maintain y and x. So we have y equals to the gradient, which is 9 over 5x, plus a constant, which is -2 over 5. And so the answer is the same as 9 over 5x minus 2/5. That checks. Okay, let's go to the next question here. Find the equation of a line which is parallel to the line y equals to 3x plus 1 and passes through 3,5, I should say. So for lines to be parallel, we know that they have the same gradient, right? So these two lines have the same gradient. So we have m1 and m2 here. So we have m1 should be equal to m2. So we have an equation here that is looking like this. And so the gradient here, we can extract it as -3 because the coefficient of the variable x, and we are aware that it is passing through this point here. So we already have the gradient, and this gradient is the same as m2. So we need to use this point here and the gradient. So we again have to look at this equation, standard equation for a straight line. And then we have the variables x and y, so we need to substitute. We have y is 5 and x is 3, so the gradient is -3. So we have x is 3, so we have that plus c. So this is 5 equals to -9 plus c, and so c is nothing but 14. All right, so having said so, we now need to get the equation. Going back here and substituting, we have y, we maintain y and x, so m is -3, and then x, then plus 14. That's x. Okay, so part C, find the equation of the line which is perpendicular to x plus 2y and passes through point 0 and 2. So for lines to be perpendicular or orthogonal, for that case, if this line has gradient 1 and this one has gradient 2, the product of this gradient should give us a -1. So we have the equation x plus 2y equals to 4, and we must always strive to make sure that this equation matches this form, right? So we have to rearrange this, and this is what we're going to have. Divide by 2 both sides. So this gives us y equals to -x over 2 plus 2. And so now you can see that gradient 1 is -1/2. So it goes without saying that since m1 times m2 is -1, so m2 from this one here, it will be 2. And so we already know that the second equation passes through 0 and 2. So we again use this equation here. So y is 2 and it's like x is 0. So definitely, even if we put the gradient here, okay, we can just show. So that's that. So 2 equals to 0 plus c, and c is 2. So we can rewrite this equation and have it in this form. So we maintain y and x. So gradient is 2. So variable x and then plus a constant that. So that's the equation. Finally, find the y-intercept of the line x plus 2y equals to 4. Okay, if you're told to find the y-intercept, then you already know that if you have this kind of a line, this is what we call the x-intercept, this is y-intercept. And as you know, at x-intercept, this is just a bonus, y is 0, and at y-intercept, that is the point where the line cuts y-axis, so we have x is 0. So from this equation, we are assuming that it is cutting the y-axis, and so the x value is going to be 0. So we're going to substitute 0 in this equation. Oops. So 0 plus 2y is 4, and so this one gives us y. 2y is 4, so y is nothing but 2. So the y-intercept is going to be this point here, 0, 2. So this is the point where the line cuts the y-axis. Otherwise, if you're asked to get the x-intercept, you would presuppose that y is 0, and so the value of x would be 4, and that would be, this point would be, okay, let me just give you the x-intercept would be 4, 0, and the y-intercept is nothing but 0, 2. So this point here, 0, 2. So that's what you have on a Cartesian plane, and that's how it is done. Thank you. Keep liking my videos and share as well as subscribing.